Hello dear students, welcome once again. In our today's video, we are going to see a very important topic, that is liquid crystals, from the topic States and Properties of Matter from Physical Pharmaceutics 1. So before we start with our today's video, please do like, share, subscribe and press the bell icon for getting updates on upcoming videos. So student, these liquid crystals are those substances which behaves both like liquid and solids, forming an intermediate which is also known as mesomorphic phase or mesomorphic state. Okay, so we will be seeing about these liquid crystals in detail today. Let's begin. So starting with the introduction. Liquid crystals flow like liquid but retain some molecule order like crystals. So we define it as liquid crystals are substances that exhibit properties of both liquid and solid. That is, they flow like liquid but have molecular order like that of the crystals. And students, remember that because of this dual nature, they show unique optical and physical properties. Okay, so represents a mesomorphic, that is intermediate state between solids and liquids. Then it is important in pharmaceutical and biological system, that is membranes, emulsions, gels, etc. Moving to next slide. So next slide is about types of matter. So students, normally we talk about three types of matters: solid, liquid and gases, right? You know that solids have definite shape and volume, liquids have definite volume but they take the container shape, and gases have neither, right? They don't have a definite shape nor volume. However, liquid crystals sits between a solid and liquid. So they are partly ordered and partly fluid. That is, they represents both. So in this, if you see, we have written that liquid crystal, it has intermediate properties, that is partial molecular order. Okay, so partially ordered and partially fluid. So you can imagine when them as a ordered liquid, they have a ordered structure but they are in liquid state. Okay, then moving to its classification. So basically these can be classified into two main types. The first one is thermotropic. Okay, so formed by changing temperature. Okay, so these are further divided into three types. The first one is nematic, then the next one is smectic, and the third one is cholesteric. Okay, so these arrangements are, or these three comes under the thermotropic type of liquid crystals. Then the second type is lyotropic liquid crystals. So these crystals are formed when amphophilic molecules like soaps or lipid dissolve in solvent. So temperature or concentration is directly proportional to the degree of ordered higher temperature for thermotropics and higher concentration for lyotropics. Okay, so and these lyotropics are common in biological membranes. So students, moving further about these three types of molecular arrangements. So in the first one, that is in the nematics, the molecules are parallel but they are randomly positioned. Then in second one, that is the semantic phase, they are parallel and aligned in layers. Okay, so we have written as layered structure. Whereas in third one, that is cholesteric, helical twisting of pneumatic layers. Okay, so hence they reflect different colors. The orderliness of molecule directly affects their optical behavior. So students, in this image, you can see the arrangement of all these three types of phases. Okay, so it has, this image represents the different phases. If you see at the bottom, the initial, we have the crystals heating, cooling. So when it is heated, it get converted into liquid crystals, and when it is further heated, it gets converted to liquid. Okay, so likewise liquid when it condenses, right? So it converts into liquid crystals, and when cooled further it converts into crystal. So this liquid crystal is an intermediate phase between the solids as well as the liquids. And again, these liquid crystals are subdivided into three types, which you can see below, right? So this differentiation is based on the positions of the molecules. Moving further, so students, now let's talk about their properties. So the first property is liquid crystals show anisotropy. So what does it mean? It means that their properties depend on direction. For example, refractive index or conductivity varies with molecular orientation, the way the molecules are arranged. Then the next point is they show optical birefringence, which means splitting light into two rays. Okay, that is double reflection of light. Then the next is fluidity, that is they still have fluidity unlike solid. They are able to flow. Then the next is electrical conductivity variation is observed, and they are thermal sensitive, that is color and phases change with that of temperature. Okay, in one line I can say that the property intensity is directly proportional on molecular order. Okay, then moving further, examples of liquid crystal compounds. So students, the common examples include, the first one is cholesterol ether, which is cholesterol benzoate. Then the other examples include lipids and phospholipids, which are used in biological membranes. Then soap water system, then DNA and protein aggregates. From the above examples, it is clear that liquid crystal behavior is not limited to synthetic material, but it is inherited in living system. Moving to next point, that is pharmaceutical applications of liquid crystals. Okay, so liquid crystals are very useful in pharmaceuticals. They are useful in drug delivery system. Liquid crystals are used to allow controlled or sustained release, that is, rate of release is inversely proportional to molecular order. That is, the more ordered, there will be a slower diffusion, right? Then, the next is transdermal formulations. So, liquid crystals layer enhances drug permeability. Okay, so it improves penetration through that of the lipid layers. Moving to the next point, that is liquid crystals helps in stabilizing proteins and peptides by maintaining hydration. The fourth important application in pharmaceuticals are useful as biomimetic membranes. Then the next one is in your creams and gels, liquid crystal phase improves textures and stability. Then they are intermediates in liposomal formulations. Okay, so these liquid crystals link physical chemistry directly to pharmaceutical sciences. Okay, so helping in formulations of various type of dosage form. Then moving to next use, that is role in biological system. So the first is cell membrane, that is phospholipid bilayer shows liquid crystalline nature. So students, did you know that your own cell membranes are made up of phospholipid arrangement in a liquid crystalline bilayer, right? So this membrane gives both flexibility and structural integrity, right? A perfect example of balanced order and fluidity. The next one is DNA and proteins. It exhibit ordered but flexible arrangement, right? So DNA strands and proteins can also exhibit liquid crystalline order when densely packed. So from both of the above, we can say that life itself depends on its mesophase behavior, right? So the last point, relevance. So understanding liquid crystal behavior helps in understanding drug membrane interaction. So that's all students in our today's video, all about liquid crystal necessary that you must know. Thank you for watching till end.